Okay, so today we're going to continue on our talking about the gas laws. So on last class, we spent some time talking about the different ways of measuring pressure and using those different units and converting in between the units. Which one do you have to use? Well, for when we get to the ideal gas law, you'll use ATMs, you'll use atmospheres of pressure, but otherwise, you can use whatever you want as long as it's consistent throughout the problem. So just like last time when you could use milliliters or liters for your solutions sometimes, it just has to be consistent. Okay, so what I'm going to do is I'm going to take us through each of the formulas on the poopy sheet and tell you about them and what they mean. Okay, so the first formula on your sheet looks like this. This has a name, it's called Boyle's Law. Boyle's Law states that, and I'm going to give you like the actual definition of it. Volume and pressure are inversely proportional. So I'm going to write that down here. Volume and pressure are inversely proportional. Okay, so let me say that to you in English. Volume. As volume gets bigger, this little Jesus fish here in the middle, let's see if this green, can you see this green today? Mm-hmm. Okay, yeah, these lines are quite a bit thicker. I'm not going to be able to get as much on a page, which is frustrating, but we'll make it through. This is the Greek symbol alpha, like lowercase alpha. And what it means is proportional to, or you can almost like think of it as an equal sign. So what something means when it's proportional, it means that as this changes, the other thing changes as well. So something that would be proportional in real life, as the price of gas per gallon goes up, people tend to drive less. So that would be an example of something being inversely proportional. They tend to drive less because it costs more to go places. Okay, so what does this mean? P stands for pressure. Pressure. And so in English, what this means is, as volume goes up, pressure goes down. Obviously, the opposite would also be true. As volume goes down, pressure goes up. So let's see. I'm trying to think of a real life example of this. Okay, so imagine your tire. How many of you do not drive? Okay, so for the two of you, this might not be the most salient example, but for the rest of us, if you drive a car, do you have a sensor in your car that tells you your tires are low on air? Mm-hmm. Many of the newer models do that, and that's a helpful thing. But also, you have a great sensor called your eyeballs that you can see when your tires get low on air. So the tire is mostly rigid, which means that it doesn't change its shape super much, but we can see it because we'll see it when it gets flat, right? Mm-hmm. So what do you do when your tires are low on pressure? You fill them up. You go to the Quick Trip and you do the free fill up, and the Quick Trip ones are super nice because they also have, like, attached to the air hose, they have the pressure gauge, so it'll just shut off when it's super handy. Back in the olden days, you had to put quarters in a machine, and you had to have a special device that measured your pressure because you couldn't know unless by looking at it. But now technology has advanced. It's great days. Okay, so what happens in your tire? If your tire is flat, you put air in. what that actually means is you are, oh no, that's a bad example. Because the container actually isn't rigid. Okay, there's not a very good. Let me keep thinking on this. Let me keep thinking on this, and I will actually give you a real world example. But I gotta keep thinking on this. Okay, so dummy. Let's take a look at number 3 and learn how to use this formula really quickly. Now, what's nice about this formula, and the reason I start with Boyle, is because it's called Boyle's law because that's the dude who discovered it. This is almost identical to another formula that we've used twice. So remember, M1 V1 equals M2 V2, N1 V1 equals N2 V2. So this is very similar to that as well. So the math shouldn't be too difficult for us. Okay, so however, we do need to maybe put down on our brown sheet the algebra. And now, because there were so many of you who asked me for help on algebra because you were too lazy to write it down, after I had written it down on here, I won't help you with algebra anymore because I'm going to give you the things to put on your brown sheet. You need to put it on your brown sheet. If algebra and you are not friends, put it on your brown sheet. Otherwise, I won't help you. So, if algebra is, and you are fine though, you don't need to do it. But if you asked me for help last week on your test, you need to write it down. Okay, so here are the 2 for solving for P. I would like to get them all on one screen, so we'll see how this works. Okay, so then writing those down should help you to solve any of the problems that we get to now in this first section on our homework. Okay, so if you're good at algebra, this is going to be an absolute piece of cake. If you're not good at algebra, we'll get you there. Okay, so on number 3, on your homework, I give you a whole bunch of things, and then even a question mark. Can I move to the next?
No.
Okay.
No.
Okay. So what I want you to do while I'm leaving this on the board, I want you to make yourself a data table of the information that I've given you. What I did not give you is which one is V1 and V2. So you need to decide that. Two nights ago, I had a dream that I was a bank robber. And I'm pretty sure that, like, my henchmen, like, I was the ringleader, obviously. My henchmen were my kid, Jake Peters, and Dylan Cetasia. And I got so angry with them for being, like, knuckleheads during the process of our bank robbery. But then, when we raided the bank vault, we discovered that also this bank was keeping drugs in it, and so we stole their drugs. And then my husband Nick was the getaway driver, and he drove us to this yacht where, like, the drugs were taken. But I have no idea what kind of drugs these were. They were like these, like, they looked, you know, like yogurt covered pretzels or like white chocolate covered pretzels. That's what it looked like. It was like bark that you broke off and ate. I can't explain it. I have some pretty weird dreams. All right, so here is 3A. I'm going to just try to make sure that I'm getting it on the video. Okay, so your data table should look like this. You have a volume, 291 milliliters, and you have 1.07 ATM. What variable do you have? Liz? You have P. How do we know that? because ATM is the unit for pressure. If you forgot and you were like, I don't know what to do, read this. Look at the things that are on the brown sheet because it tells you right at the bottom, these are the units for pressure. Okay, and then we have another volume, and that's question mark. And then we have another ATM, so that also must be pressure, right? Okay, so now what we need to do is determine which one is V1 and which one is V2. So because this one is first in the list, I'm just going to identify those as 1 and 2. But now I can't just do that to P. I actually have to look at my sheet. And so here, because it says 291 milliliters at 1.07 ATM, that means those two things go together. So that's my P1, and my P2 is the 2.14. Okay, so now I'm going to, I've got my data table. What do I need to have next? I need to have a formula. And so my formula should be, if I'm looking for V2, I should choose the one that's solving for V2. And now I can put my numbers in, and it really is that simple. Now you're going to need to write down your correct unit, but also your correct number of significant figures. I get 145.5. Oh, I like this. Like, there's almost nothing I like about the Smartboard app. I think it's actually kind of terrible, but look what I can do. I can use my hand to be my eraser. Okay, what should be my unit? Milliliters. And I can figure that out from two different ways. I can cancel out the ATM units here, but also I can look back at my data table and I can see, oh, I was looking for volume. That must be the milliliter unit. How many significant figures should I have?
3.
But I had 4, so I should really put that line above the 5. If you want to round, you may also do that. Okay, thumbs up, thumbs down, thumbs medium. How was that? Okay, good. All right, I am going to do another one of these with you. Then we'll do something a little bit harder. All right, so let's do 3B. Make a data table for me. So I'm going to say that V1 equals 1.25. So that must mean that P1 here is 755 mmHg. V2 again is question mark, and then P2 is 3.51 ATM. Okay, so that's good. I'm going to choose my formula. You do. Yes, you do. So remember what I said, it doesn't matter which unit you have, it just has to be consistent. This is not consistent. They're two different things. So which one do you want to use? Do you want to use millimeters of mercury or do you want to use ATM? Well, I want to use ATM, so we'll use that. So that means I'm going to convert 755 to ATMs. Okay, so how do I convert my units? Well, I know from my formula sheet that 1 ATM equals 760 mmHg. So mmHg goes on the bottom of this fraction. What number goes next to it? 760. And then 1 ATM goes on top. And I get 0.993. So now I know that this is the number that I have to put in here for P1. All right, so then V2 is equal to 0.993 ATM times 1.25 liters. Running out of space. P2 is 3.51 ATM. So then that means our answer should be, now I'm just gonna, because I have this original number in my calculator, I'm not gonna clear it, I'm just gonna use that same number. So if you clear it and you round, we will have slightly different answers, but it shouldn't matter. So I get 0.3538, and my unit is liters. How do I know that? Because these units cancel out and I'm left with liters. How many significant figures should I have?
3.
And so this should be my answer. Mm-hmm. All right, so the rest of these in question number 3, the rest of those parts are all the same. So just take a look at those. You just have to be careful that you're choosing the right formula and that your units are consistent. I would like us to do number 4 next. So work on a data table for number 4. Or perhaps maybe you want to start by just giving it a nice read.
Can you guys really drink my locker?
Yes, 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 yes. I could not make it through a class without a beverage. Also, it's a good strategy for staying awake. All right, so number 4 reads, if the pressure exerted on the gas in a weather balloon decreases from 1.01 ATM to 0.562 ATM as it rises, what will be the volume at the higher elevation if there are 15,000 liters of gas at its lower elevation? Okay, so this is a lot of words. You're going to have to pay attention to this pretty clearly. So what I'm going to do is first get all of my variables with their numbers here. And I'm not going to identify P1 and P2 until I'm ready with everything else. Okay, so now if you just were to write P1, P2, V1, V2, we have no guarantee that that's correct. So what we need to do is go back to our problem and read. Okay, so it says that the gas in a weather balloon, the pressure decreases as it rises. So if here is my little air balloon, a hot air balloon, at the lower elevation, P equals 1.1 ATM. Here, at the higher elevation, it's 0.562. Okay, so where does the 15,000, which of the 2 balloons does the 15,000 liters go with? This? The lower one. So if we want to say that P1 is the 1.01 ATM, that means that V1 is the 15,000. Making those other two the V2s. So in this case, we would be correct to say that P1, P2, V1, V2, like they go in order in the way that I wrote them down here. That is a coincidence. So don't let yourself be fooled into thinking that you don't have to read when you actually do. All right, so you can do that one on your own. Finish the rest of it. Let's switch gears for a little bit. I'm going to clear this screen, and I'm going to tell you about the second equation on your formula sheet, Charles' law.
I think it's so funny because the last one was Boyles and this was Charles, and it reminds me of Brooklyn Nine-Nine.
Okay.
Yeah.
I don't understand your reference because I've never seen the show.
There's a character named Charles Boyle.
Oh,
Yeah.
well, look at that. I did not know that. Okay, so you've already experienced Charles' law in your life. Have you ever taken a jug of an almost empty jug of milk out of the fridge and put it on the counter for a little bit?
No.
Okay. Have you ever taken a bottle? Do you guys have bottles of soda? Have you ever had a a 20 ounce or a 2 liter bottle of soda? Okay, so do you ever notice that sometimes when you put it, when you take it out of the fridge, it's compressed or it's flat in the middle? What you're experiencing is Charles' law. So volume and temperature are directly proportional. So what does that mean in English? As temperature goes up, as temperature increases, volume also increases. But the reverse is true as well. As temperature goes down, volume also goes down. So when your soda bottle, we're going to pretend that this is my soda bottle here. When your soda bottle is sitting out on the countertop, it's at room temperature. The gas inside it's at room temperature. And then when you put it in the refrigerator, it gets to be at refrigerator temperature, which is usually about 33 degrees. Quite a bit colder, hopefully, if your heat didn't turn off, than in your room temperature. So what will happen is, because the volume will go down, is the bottle will shrink in on itself because there's just the gas is taking up less space. And so that's why you see it flattening or shriveling up kind of. Sometimes when you take the bottle out of the fridge and put it onto the countertop, if it's been in the fridge for a while and you put it on the countertop, it gets that really rigid feeling. That's because the opposite is happening. So as temperature is increasing, the gas is filling up more of the volume, and that's causing there to be a bulge, I guess. I don't know how else to say it. Okay, so volume and temperature are directly proportional. As one goes up, the other also goes up. Let me give you the algebra for these. It's a little bit more tricky because you've got something always as a denominator. What? don't understand how that works. Oh, that's. Do you have all of those formulas written down?
I don't know.
Okay, no problem.
Lots of smiley faces.
What'd you say?
So lots of smiley faces.
Because I wanted to see. I'm trying to figure out my pens here. And then I remembered Creative Pen. And you can do lots of different fun things. That's a little lame. What does this do? Oh, snowflakes! Oh! What did that do? Oh, it's just okay, that's fun. Look, it's snowing. It's snowing in our chemistry.
It's snowing outside too.
I think it's beautiful. I think the snow is lovely.
It would be better if it snowed.
Today?
Yeah, I think it looks beautiful out there.
I love it when it's snow.
I think it's lovely. I'm okay with it. Jake kept being like on the whole way to school. He was like, I can't wait for summer. I can't wait for summer. I can't wait for summer. And I was like, oh my gosh, you're terrible.
Winter is such a bad time.
No, it's not. It's lovely. I disagree.
The only time winter is acceptable is when it's 10 inches of snow and no school for a week.
Yeah. 10 inches of snow would not get you snow for a week.
Okay.
I mean, no school for a week.
At least get off for the day.
Maybe.
We were off of school for a week in like elementary school because we had like,
Remember when it was like super duper cold and they wouldn't let you go to school?
it was like negative 50.
Those are great days.
Yeah, we're never gonna have those again. Well, at TR, when I went to the middle school, so someone was driving away from the police and crashed into a power line next to the school. So they canceled school because there's no power.
Dub.
Honestly, I'd be rude for the guy who was trying to get away.
I mean, yeah, but like you'd be a local hero, at least with the kids. All right, let's look at number 7A. Okay, so before we talk about this, we have to deal with our friend temperature. So you cannot use degrees Celsius to to measure temperature of gases. And the reason for that is a lot of times gases exist in really nice conditions at 0 degrees Celsius, which is when we know water freezes at. But we can't multiply by 0 and we sure as heck can't divide by 0. And so to deal with that, when we are using our gas laws, any of them, temperature must be in kelvins. Now, converting from degrees Celsius to kelvins is pretty simple. You're just going to add 273 to whatever you get. So it's something that you could even do in your mind for some things, which is nice. But use your calculator if you have to. Okay, so I'm going to start my data table for 7A. I've got 25.0 liters of my gas, and there it's at 0 degrees Celsius. Okay, great. I know that these are V1 and T1 because they're grouped together. So 0 degrees Celsius is the same thing as 273 kelvins. And that's what I can do in my mind. Volume 2, my paper says, is 50.0 liters. And T2 is question mark degrees Celsius. So that means that when you get to the end of your problem, you will need to convert back from kelvins to Celsius. Okay, next step, choose my formula. Nope. P1, P2 divided by P.
Two ones and twos.
Did I get that? Did I mix that up?
Yep.
It doesn't work for me to do this. I have to write the original formula out. T2 would be V2. Yeah, that's right. Okay, so then let's put our numbers in. Remember, we're using 273. You'll figure this out if you like. You'll get a 0 as an answer, and we know we can't have 0. So you'll see that it'll be wrong. Hopefully. So 273 times 50 divided by 25 is 546. What should be your unit?
Degrees Celsius. Oh, Kelvin.
It is Kelvin. Now, in order to calculate degrees Celsius, I'm just going to subtract that 273. And I get 273 kelvins. Yes, ma'am. Yes, you're right. You're right. Thank you. What did I do? Yes, you do. You have to go from Celsius to kelvins, and then from kelvins to Celsius. Yep. It's a little bit tedious.
Wait, so 546 is Kelvins, not Celsius.
Mm-hmm. Yeah, because look at your math here. You can cancel off liters, but Kelvin is the unit that you're left with. Let's do another one of these. Can I erase this? All right, let's do B. Make a data table, and probably you will need to calculate kelvins. That's a janky. Okay, choose your formula. Now, I would say that a mistake that I see, there's another variation of Charles' law that uses pressure. It's the third formula on your sheet, and I just keep using that instead. My bad. A mistake I see a lot is even if you calculate kelvins from degrees Celsius, the temptation is still there to use your original number. So just be careful. Did anybody get a final answer? hang on for a sec, Liz. Want more people to get a final answer.
Today's a normal day, right?
It is.
Are they putting up music today or?
The 22nd. Any more people get a final answer? Joseph, what'd you get?
But Miss Blaze just going, so we have to either go for 5,
307.65.
Okay, what's your unit here?
So, he invited me to the Zoom
Thousand?
Florida.
Kelvin?
It is Kelvin. All right, so then your final answer should be 34.6. Did everybody else get that? Michelle?
Don't we only need two significant figures because the 25 degrees Celsius?
Oh, yes, indeed, we do.
Well done.
All right, so let's take a look at. Yeah, oh, yes, Joseph. Yes, go ahead.
How do you get like the final answer?
Oh, how do I get the final?
Yep.
I subtracted 273 to get to there.
You got it. Thank you.
You're welcome. Alrighty, so let's turn to the back page now. And let's look at number 8. Number 8 is a word problem. Word problems are tricky because you have to read. But if you make a data table, a word problem then becomes like one of the ones on this page instead. Okay, so number 8 says if a 45 milliliter sample of gas, okay, so I see 45.0 milliliters. And when I see a number, I like to write it down. Which one of the variables is this? Is it P, V, or T? What'd you say, Connor?
V.
It is V indeed. How do I know that? It says milliliters. If this sample of gas at 26.5 degrees Celsius, that one is a little bit easier, like degrees means temperature, is heated to 55.2 degrees Celsius, what is the new volume of the gas sample? All right. Which one do we want to call V1? The top one or the bottom one? So then which one has to be T2? 26 or 55? How do I know? I have to look back at my problem. Always we look for the word of or at. So if I see of gas at 26.5, that means that these two numbers are describing the same substance.
You have the 1 by the second there.
Oh, I do. Well, I don't know how I did that. I think I must be working on hungry, tired brain. Oopsie. All right, choose your formula.
Can we keep it as Celsius because they're both Celsius and then convert later, or do we have to convert right away?
You should never use Celsius in your calculation. So in this case, you'll see that you'll get the same answer. And that's why it took me a long time to answer you, Connor, because if you let it be okay for yourself to use degrees Celsius for some things, you'll get out of the habit of using it for all the things, and then you'll do yourself a disservice. So I'm going to calculate that in kelvins. 299.5 and 328.2. I wish you could choose a default. Okay, so if we do V2 see, I was going to just start writing 55.2. So sometimes what I'll do is, like, without even writing the degrees Celsius down, I'll just convert it first and then write that in my data table. So I get 49.3 from my calculator. Did everybody else get that as well? What's my unit? Millimeters. And I have 3 significant figures. So really, these problems aren't difficult. You just have to be able to, like, discipline yourself about the reading of it. All right, I want you to skip numbers 11 and 12 for now. And because I can tell you guys are getting a little bit weary of this, you have the rest of class time to work on this. I would spend, like, especially if you are, like, a little bit worried about your grade, maybe take 5 minutes to check your heyday and then spend the rest of the time working on this so that you can get it checked before you leave today. Although it's not due until next week, it would probably be a good idea to get it done while it's fresh in your mind. So discipline yourself to work through the pain.
You said skip 11 and 12.
Yes, for now. Everything else you can do.